A-level mechanics, equations of motion, vertical motion. We'll consider the vertical motion of a particle when moving freely under gravity. Now we've seen that when a particle moves with constant acceleration, we can use the Suvat equations. We've seen them before, and they tell us about the motion of a particle when moving under constant acceleration. If a particle is projected vertically, and we ignore air resistance, it'll have a constant acceleration of g downwards, where g is the acceleration caused by gravity. At any given place, all objects fall with the same acceleration. On Earth, that's about 9.8 meters per second squared. On the Moon, g is equal to 1.625 meters per second squared, and on Mars, g is equal to 3.71 meters per second squared. These are vector equations, so when tackling a problem with objects projected vertically, we must first choose which direction is positive. Usually we choose up as positive, in which case g is equal to minus 9.8 meters per second squared, because g acts downwards. Now we can take g more accurately. G is equal to minus 0.980665 meters per second squared, or more approximately, and take g equals minus 10 meters per second squared. Let's consider an example, example 1. A stone is projected vertically upwards from ground level with a velocity of 14.7 meters per second. In part A, we're asked, how long will it take to reach its maximum height? Well, to solve this, we need to decide which direction is positive, so let's take up as positive, in which case A is equal to minus 9.8, U is equal to 14.7. At the top, it'll have no velocity, so V equals 0, and we're trying to find out T. So we're going to use the equation V equals U plus AT. Now that gives us 0 equals 14.7 minus 9.8t. So t is equal to 14.7 divided by 9.8, which is 1.5. So it'll take 1.5 seconds to reach its maximum height. Now in part B, it asks what is the maximum height? Well, for part B, we've got A is equal to minus 9.8, we've got U is equal to 14.7, and we have T is equal to 1.5. We're trying to find S. Now, S equals UT plus a half AT squared. So S is 14.7 times 1.5 minus a half times 9.8 times 1.5 squared. And if we work that out, it's 11.025 meters. So the maximum height it reaches is 11.025 meters. In part C, we're asked, how long will it take before it hits the ground? Well, if it hits the ground, its displacement will be 0. It's back where it started. So A equals minus 9.8, U equals 14.7, S equals 0, and we're trying to find T. So using S equals UT plus a half AT squared, 0 equals 14.7t minus a half times 9.8 times t squared. So 4.9t squared equals 14.7t. So either t is 0 or 4.9t is equal to 14.7. So t is equal to 3. So it hits the ground after 3 seconds. Example 2. To find out how deep a well is, a girl drops a stone and times how long it takes to hit the water at the bottom. She times it at 2.4 seconds. In part A, how deep does she calculate the well is? Well, to solve this, taking down as positive, G is 9.8, U is 0, T is 2.4, and we're trying to find S. So, using s equals ut plus a half at squared, we have s equals 0 plus a half times 9.8 times 2.4 squared, which works out to be 28.224 metres. So she calculates the depth is 28.2 metres. If she can only measure the time to the nearest 0.2 of a second, in part B we're asked, what is the range of depths the well could be? Well, if she can measure the time only to the nearest 0.2 seconds, the minimum time could be 2.2 seconds, in which case s is equal to 0 plus a half times 9.8 times 2.2 squared, which turns out to be s is equal to 23.716. Alternatively, the maximum value t could have is 2.6 seconds, in which case s is equal to 0 plus a half times 9.8 times 2.6 squared, which is 33.124. And so we see the depth lies between 23.7 metres and 33.1 metres. Now this is in fact a spread of almost 10 metres, in fact 9.4 metres, for the possible depth of the well. Example 3. A stone is projected upwards from the top edge of a building. On the way down it misses the building. It passes the top of the building on the way down after 3.4 seconds and strikes the ground after a total time of 4.8 seconds. Calculate the height of the building. Well, to solve this, let the initial velocity of the projectile be u. Take up as positive, and as the projectile passes the top of the building, we have s equals 0, t equals 3.4, a equals minus 9.8, and u is capital U. So, using the equation s equals ut plus a half at squared, we have 0 equals u times 3.4 minus a half times 9.8 times 3.4 squared. So 3.4u is equal to 4.9 times 3.4 squared. Dividing by 3.4, we have u is 4.9 times 3.4, so u is 16.66. For the total flight, let the height of the building be h. So u is 16.66, a is equal to minus 9.8, t is equal to 4.8, and s is equal to minus h. This gives us minus h equals 16.66 times 4.8 minus a half times 9.8 times 4.8 squared, which equals minus 32.928. And so h is equal to 32.928, and we get the height of the building is 32.9 metres. Let's have a look at one more example, example 4. A particle is projected up from ground level with a speed of 30 metres per second. When will it be at a height of 35 metres? Well, to solve this, let's take up as positive. We have u is equal to 30, a is equal to minus 9.8, s is equal to 35, and we're trying to find out the value of t. So, using s equals ut plus a half at squared, we've got 35 equals 30t minus a half times 9.8t squared, which is 35 equals 30t minus 4.9t squared, which gives us the quadratic equation 4.9t squared minus 30t plus 35 is equal to 0. Now that doesn't factorise, so we can use the quadratic formula t equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and we substitute a equals 4.9, b equals minus 30, and c equals 35. This gives us t equals minus 30 plus or minus the square root of minus 30 all squared minus 4 times 4.9 times 35, all divided by 2 times 4.9. Well, that simplifies to t equals 30 plus or minus the square root of 214 all over 9.8, which works out t equals 30 plus or minus 14.62874 all divided by 9.8, or t is equal to 4.55395, or t is equal to 1.5685. Now this gives us two answers, which might seem unusual, but if we look at a diagram, we see there are two answers. The object will pass the height 35 meters twice, once on the way up and once on the way down. And so we have the times are t is 1.57 seconds on the way up and 4.55 seconds on the way down.